Hello. Welcome to Action Squared channel. In this video we are interested in finding the sum of the first n terms of the series 1 plus 2 plus 4 plus 7 plus 11 plus 16 plus 22 plus, etc. But before working on this problem, let's do a quick review about sequences and series. A sequence is the organization of elements of any type in a specific order, where repetition is allowed. The sequences can be finite or infinite. And the elements in a sequence can be disposed in an arbitrary order or follow a predefined direction, such as ascending, descending, or alternating order. The mathematical notation to designate a sequence is having its elements enclosed by braces and separated by commas. Usually, a term in a sequence is referred to ai, where I indicates its position. The first term is a1, the second is a2, and so forth. The last term is referred to an. When dealing with infinite sequences, an may refer to the last term of interest. Some sequences that obey rules of formation receive special names, such as arithmetic progression. An arithmetic progression is any sequence where the difference between two consecutive terms is equal to a constant denoted by d equals ai minus 1. Example, the sequence of the natural numbers, where the constant difference is equal to 1. Geometric progression. A geometric progression is any sequence where the ratio between two consecutive terms is equal to a constant denoted by r equals ai over ai minus 1. Example, the sequence of powers of 2 for natural numbers, where the constant ratio is equal to 2. Harmonic progression. A harmonic progression is any sequence obtained by taking the reciprocal of an arithmetic progression that does not include 0. In the harmonic progression, a term is equal to the harmonic mean between its predecessor and successor. Example, the sequence of the reciprocal of the natural numbers, starting from 1. Fibonacci sequence. The Fibonacci sequence is a special sequence where each term is the sum of the previous two, starting with 0 and 1. A term in the Fibonacci sequence is usually referred to fn, so f1 equals 0, f2 equals 1, and fn equals fn minus 1, plus fn minus 2, for n greater than 2. Hence, the first 10 terms of the Fibonacci sequence are 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Some sources consider the first two terms of the Fibonacci sequence being f1 equals 1 and f2 equals 1. The Fibonacci sequence is related to the irrational number phi equals 1.618, also known as golden ratio, because the ratio between consecutive terms tends to phi when n increases. What about series? A series is the sum of the terms of a numeric sequence. Thus, the sum of an arithmetic progression is an arithmetic series. Just as the sum of a geometric progression is a geometric series. The sum of the first n terms of an arithmetic progression is equal to n over 2 times a1 plus an. The sum of the first n terms of a geometric progression is equal to a1 times 1 minus r to the power of n over 1 minus r. It is possible to compute the sum of an infinite geometric progression when the modulus of the ratio r is less than 1, as higher terms are negligible and the series converges. So, an infinite geometric series, with r less than 1, is equal to a 1 over 1 minus r. Now, back to our problem. Our series 1 plus 2 plus 4 plus 7 plus 11 plus etc. is not an arithmetic series, as there is no constant difference between two adjacent terms, neither a geometric series, no constant ratio between two adjacent terms. Thus, to calculate the sum of its first n terms, let's see if there is a rule governing the series. A good attempt is to write each number of the sequence in terms of the first one. a1. A2 equals a1 plus 1. A3 equals a2 plus 2. Or replacing a2, a1 plus 1 plus 2. Similarly, a4 equals a3 plus 3, or a1 plus 1 plus 2 plus 3. Extending that to term an equals an minus 1 plus n minus 1. Or a 1 plus 1 plus 2 plus 3 plus the remaining terms up to n minus 1. Can you see the pattern? A 1 is present in all terms, and considering that 1 can be defined as an arithmetic series of just 1, from the second term on, each of the terms can be seen as arithmetic series from 1 up to the n minus 1. To find the summation from I equals 1 to n of ai, let's replace the terms a1 to an by their equivalent expressions, and reorganize them. The result is n times a 1 plus the sum of arithmetic series. Now, a 1 can be replaced by its value 1. Remember that the sum of an arithmetic progression, or AP for short, is given by the number of elements over 2 times the first element plus the last element. Applying this formula to each of these brackets, the first element is always 1, while the number of elements varies from 1 to n minus 1. As the number of elements is equal to the last element, let's call it using the variable j. Hence, our series is equal to n plus summation from j equals 1 to n minus 1 of j over 2 times 1 plus j. Let me know in the comments if you have a different approach to find this solution. Finally, a little treat. Can you find the sum of the first 10 terms of the series below? 1 plus 2 plus 5 plus 12 plus 27 plus etc. If you like this content, please support us by liking this video, subscribing to our channel, and turning the notifications bell on. Hope to see you in the next video. Thank you.